So in the last episode, I actually talked about convolution and the Sobel operator, and go check that out if you haven't already, because that'll be a prerequisite for this video where I'm going to be talking about other operators and what they're useful for. Throughout computer vision, there's been lots of different operators that have sort of followed the same pipeline that the Sobel operator uses, but there have been many different tweaks that have been found along the way to help improve it, make it more robust, and we're going to be talking about just a few of the more popular options. So just as a quick recap, we actually are finding the edges in an image, and we do this using convolution, and we use filters. And the most popular filter back in the day was actually the Sobel filter, which finds the gradients in both the x and y directions, and then you find the magnitude between them. The first operator is the Pruitt operator, and it's very similar to the Sobel operator. However, we're not going to be putting as much weight in the center of the kernel like we do with the Sobel operator. This allows us to have a faster processing time when it comes to finding the edges of the image. This might be useful for super fast video processing or when you need a ton of images at one time. This is very common to have, but it may be very prone to a lot more noise, whereas the Sobel is more robust. I should also point out that both of these algorithms were discovered in 1970, but I can't help but think about the classic homework meme, whereas can I copy your homework? Yeah, sure, but just don't make it look so obvious. So the next operator I want to talk about is the Roberts cross operator. This one actually predates both the Sobel and the Pruitt operator. It goes all the way back to 1963, and it was actually designed for having super fast computation speed, and it's great at detecting edges in diagonal directions. However, it's not as powerful when it comes to detecting the normal horizontal and vertical directional edges like the Pruitt and the Sobel operators. Up next, we have the SCAR operator, and much like the Pruitt and the Sobel operator, it places more emphasis and more weight on the center of the kernel. This allows the algorithm to become better at detecting the edges at the expense of being more computationally expensive. And with this more robust system, it actually allows the images to become rotationally invariant. That means that you can rotate the image in any direction, and it's still going to detect the image edges as perfectly as it would if it was straight up and down. A more heavy-duty filter like this is actually really good for medical imaging or industrial inspections, and is really good when you need more attention to detail in the image. Think of it as more of a beefed-up Sobel operator.
Wait, you bred a pig?
Sure did. Most genetically perfect one in the contest.
Oink. Oh my god!
Yes, he's something, isn't he?
Are those fists?
Damn right, show him, pig.
Up next is actually a really interesting filter called the Kirsch compass operator. And this one actually works by setting up 8 3x3 filters that rotate in a positive and negative values throughout its kernel. This allows the algorithm to detect edges in the 8 compass directions, and an operator like this is definitely way more computationally expensive. And here is just a reminder of what that kind of math would look like. Next, we have the Laplacian of Gaussian, and besides being a fun word to say, I'm actually going to go more in depth in this in a different video in the future. This one actually works by taking the second derivative of the image instead of just one derivative of the image pixels. So if you forget about all that kind of stuff, go watch the earlier video where I talk about the derivatives, but I will be making a video about this in the future. Same thing with the Canny edge detector, and it's a very popular edge detection algorithm, and I'm going to go over that in its own separate video. So for the remainder of this video, I'm just going to play out some images so you can see side by side what these filters do to the image and how they compare it against each other. And in case your attention span is short, here's a Subway Surfers clip. This is Ryan from the editing room. I just wanted to say that even though it may not look like it, these filters actually are doing something, and it varies between different images, and you're probably seeing this on your cell phone, so it probably won't make the biggest difference. But the filters are doing things, so take a look at them here and enjoy.